Alrighty, so today we're going to work on a process called completing the square. Okay? Completing the square is the process to go from standard form to vertex form. Okay? So on your after party, you went from vertex form to standard form because that's easy. We just multiply it out, combine like terms. Okay? To go from standard form to vertex form takes a little bit more manipulating. Okay? The idea, the reason it's called completing the square is because to go from standard to vertex form, we've got to create a binomial squared. Okay? That's what that square means. It's not the shape square. It's as in like squaring a binomial. Okay? So we're gonna come up with a process that creates this binomial squared. Okay? It might seem a little weird at first, and this is going to be one of those things where I just need you to kind of roll with it at first, see an example or two, and then we can start hashing through questions. Okay? But I'm going to show you a process that will work every time as long as you get the process down. Okay? All right. So one thing that's very important to notice is while some of these steps might look similar to factoring, this is not factoring. Okay? Some of it might look similar, but this is not factoring. This is a separate process called completing the square so that we can create that binomial squared. Okay? All right. Here's our first one. Y equals x squared plus 2x plus 6. Do you agree that this is in standard form? Okay. Let's go ahead and get this written down. No, you can save that till the end. At the end, once we get it in vertex form, we're going to talk about it a little bit. Okay. So the first thing you're going to do is take your C value and scooch it out of the way. Okay, you're going to move it over. So I'm going to rewrite this as y equals x squared plus 2x. And then I'm going to move and leave myself some space, and I'm going to write plus 6 a little further over. I haven't changed anything, right? Oh, sorry. It should just be y equals, not y squared. Sorry. Okay, I haven't changed anything. I'm just giving myself some room to do the process. Okay? All right. Next thing you need to do is you need to find your b value. What's our b value? 2. Okay? So find your b value. And first thing we're going to do is half it. We're going to half our b value. So I'm going to take 2, and if I half it, I'm going to divide it by 2, and what am I going to get? 1. So you're going to half it, then you're going to box it. The answer you get, you're going to box it. And I'll tell you why in just a few minutes, but for now, just go with it. So we halved our b value, then we boxed it. Okay? Just let's go through the process, and then I'll explain how it worked, okay? Half the b value, divide it by, then we box it. Now we're going to square it. What's 1 squared? 1. Okay? This number that you get right here, this 1, now we're going to write it back into our equation. Okay? So it's a positive 1, so I'm going to put plus 1. I'm going to write it. Am I allowed to just add 1 anywhere I want? Have I messed up this equation now? Yeah, I've added 1 to it, right? So I have to counteract that 1. Okay? I have to counteract that 1. So if I add 1, how can I counteract it and make it act like we didn't do anything? Yeah, or I could add 1 to the other side, or could I subtract 1 on this side? Would that be the same? If I add 1 and subtract 1, haven't I essentially added 0? Yeah. Okay? So I've halved it, boxed it, square it, write it, counteract it. Okay? That's our process. Now let's see why I did all those things. The whole purpose is to create a binomial squared, correct? Okay, look at this trinomial right here. Take a sec and off to the side somewhere, factor that binomial, or sorry, trinomial. Factor x squared plus 2x plus 1. Don't do it right under, do it kind of off to the side somewhere. You done factoring? What'd you get when you factored it? X plus 1 times x plus 1, which is x plus 1 squared. I told you our goal was to create a binomial squared, right? Did we do it? Yeah. That's what this process does. Creates that binomial squared. Now, here's the cool part. You're not going to have to factor that trinomial every time. Okay? The reason I had you box this one, the reason I had you box this is because that comes right here. Okay? That comes right here. So now I've got to finish up with this 6 minus 1. What does that become? So plus 5. So here's our vertex form. Y equals x plus 1 squared plus 5. Okay? Now, you don't have to follow this process. If you can kind of look at it and create your binomial squared, that's your call. Okay? But this process will work every time, and it's a great mnemonic way to remember what we're doing. Okay? So we halved it. It's half it, box it, square it, write it, counteract it. Okay? So that's how you've got to figure out what is going to be how are we going to create that trinomial. Because if you think about going backwards, multiplying out a binomial squared, you're going to have 2ab as your middle term. So in that middle term, this 2a, or 2x, is technically 2ab. So I'd figure out what just ab is to get my last term. That's to get the last term, the b squared. Okay, let me get his question, I'll get yours. The reason you box it is so that you know you won't have to factor each time. You can just write it in for your binomial. Okay, Ethan? I'm going to write it at the end, but if you want to write it, it's half it, box it, square it, write it, counteract it. Okay, think about this graph now. What's the vertex? Or sorry, is this vertex form? Yeah. A times x plus h squared, x minus h squared plus k. What is the vertex? Negative 1, 5. What's the axis of symmetry? Okay, as an equation, x equals negative 1. What's the y-intercept? Where should I look for the y-intercept? No, it's not 0, 5. Huh? Yeah, I could plug in 0, but couldn't I also go right back up here to standard form? Yeah, what's my y-intercept? 0, 6. Which way does this parabola open? Up. So if I have a vertex at negative 1, 5, and it opens up, how many roots does it have? How many real roots does it have? 0 real roots. No, not from my graph. You have to go through the processes like we did earlier this week. Okay, let's try it again. Y equals x squared minus 3x plus 1. Okay, so tell me what I do first. Yeah, move the 1 over. So kind of like a mini first step, you could say move it. Okay? So y equals x squared minus 3x. I'm going to move the 1 over. Okay? Which value do I go grab? B value. Okay, what is the b value? -3. All right, I half it. -3 divided by 2, can that simplify anymore? Okay, leave it as fractions. It's easier to square. Okay, so I'm going to go ahead and just box this because that is it halved. Okay, so I half it, box it, then square it. When I square -3/2, what do I get? 9/4. Half it, box it, square it, write it. So plus 9/4. And then how do I counteract it? Minus 9/4. Okay? All right. This turns into our binomial squared. So it's going to be x. Where do I get the number that goes in here? Yeah, from the box. What's in our box? -3/2. So x minus 3/2 squared. Then I have 1 minus 9/4. So I could rewrite 1 as 4/4. So 4/4 minus 9/4 minus 5. All right, what's the vertex? Good. And what's the axis of symmetry? Oh, it's written right there. Sorry. And what's the axis of symmetry? Good. The vertical line through the vertex, so x equals 3/2. Make sure you have the x equals because it has to be a line. All right. Let's keep going. Oh, yeah. Yep, it's a vertical line through the vertex. So it has to go through the x value. Okay. Y equals 2x squared plus 4x plus 5. Now, the completing the square process only works when our a value is 1. So we're going to have to deal with that too at some point. Okay? But it's not much harder. It's just like one more step. All right, so first thing I do is still move the 5. All right, so I'm still going to write this as y equals 2x squared plus 4x, and then give myself some space and add the 5. Okay. I have to see what my a value is. I have to check that my a value is 1. Is my a value 1? No. What is my a value? 2. So because 2 is my a value, I have to pull out the 2. Now in this case, 2 happens to go evenly into 4, so that's nice. But it doesn't matter whether it goes in evenly or not. Whatever the a value is, you must pull it out. Okay? So I'm going to rewrite this. You're only pulling it out of these 2, though. So I'm going to rewrite this as y equals, my a value is what? So this is 2 times, what would be left? X squared, and then on this one, plus 2x. Okay? And I'm going to leave the space inside my parentheses, because I'm going to write it inside the parentheses. And I have my plus 5 on the outside, and I'll still counteract on the outside. All right. Now, once I have it with an a value of 1, now I can get my b value. What's my b value? 2. So I'm going to half it. What do I get? 1. Box it. Square it gives me 1. I'm going to write it. Now we have the part where we have to think a little bit more is counteract it. Okay? I've written in a plus 1. But that plus 1 is really being multiplied by what? By 2. So what have I really added in? 2. So when I counteract it, what do I have to do? Minus 2. Y'all see why? Anyone not sure why I did that? Okay, cool. So this 2 stays out here, so I have y equals 2 times. What's my binomial going to be? X plus 1 squared. Where'd this plus 1 come from? The box. Okay. And then 5 minus 2? Plus 3. All right. What's the vertex? Negative 1, 3. And what's the axis of symmetry? Oops, yeah. Okay. What? The axis of symmetry? The axis of symmetry is always a vertical line through your vertex. So if this is the point negative 1, 3, vertical lines are always in the equation x equals, right? So it's x equals that x value. Okay? All right. Let's try again. Okay, first step. I can't pull out the 3 yet. I got to move the 2 first, right? Okay. So y equals. Now, could you start to do both of these, the move it and the pull out the 3 in the same step? Yeah, as you get more comfortable with it. Okay, but for now I'm going to go ahead and write these as separate steps because I want you, when you go home this weekend, to be able to see what we did. Sorry, I can't see where the back button was. Okay, so 3x squared minus 3x plus 2. Okay, now what do? Pull out the 3. Is it because this is 3 and this is 3? No, it's because it's my a value. It just happens that it works out nicely. Okay, so here's 3 times x squared, what? Minus x, and I'm going to have my space, oh, sorry, thanks, minus x, there's my space, plus 2. All right, so what is my b value? Negative 1. I can picture a 1 here, right? So negative 1, half it, I get negative 1/2. You don't do a GCF. No, it's whatever the a value is, whatever the value in front of x squared is. Okay? So there's it halved. Box it, square it. What's negative 1/2 squared? 1/4. Write it. Okay, how am I going to counteract it? Good, because 3 times 1/4 is 3/4. That's what I've added in. So I counteract with minus 3/4. Okay? So I'm going to get y equals 3 times what? Good. Then what? This is 4/4, or sorry, 8/4. 8/4 minus 3/4 is 5/4. Gabby, did you have a question? You got it? Okay. What, Shelby? How did I go from this to this? Okay. If you were to factor this, you would get x minus 1/2 squared. But a shortcut so that you don't have to factor each time is this boxed number right here. That boxed number is what this factors into, is x minus that squared. Okay? All right, vertex. 1/2, 5/4, axis of symmetry. X equals 1/2. No, because 2 is 8/4. This 3/4? Okay, this 3/4, it was my counteract step. So I added in 1/4 times 3. So I added in 3/4. So to counteract it, I have to subtract 3/4. Okay? Okay. We good? All right, let's keep going. Y equals negative 2x squared minus 8x plus 1. Nope. You knew the answer to that question. All right, so I'm going to rewrite this. Okay, what do I have to pull out? Negative 2. When I pull out negative 2, what do I get? X squared plus 4x, right? That's an easy spot to mess up right there. Okay, leave space in your parentheses, plus 1. Because it's not a GCF. You're not pulling out a GCF. You're only pulling out the A value so that you have an A value of 1 inside the parentheses so that you can complete the square. Okay? Okay, I want you to half, box, and square and figure out what I am adding in. And if you think you can keep going, go for it. All right, so what's my B value? 4. Half it, what do I get? 2. Box it, square it, what do we get? Write it, plus 4. Okay. Yeah, why is it plus 8? Good. Negative 2 times 4 is minus 8. So I've really subtracted 8 from the function. So to counteract it, what do I have to do? Add 8 to the function. Does that part make sense? Uh-huh. The reason is when I write this 4 here, I'm not just adding 4. I'm really adding negative 2 times 4. And then I counteract it by doing the opposite. Okay? All right, next step, how do I rewrite this? Not x plus 4 squared, x plus 2 squared plus 9. Remember that this number comes from the box. Because if I multiplied out x plus 2 squared, I'd get x squared plus 4x plus 4. Okay, vertex. Negative 2, 9. Axis of symmetry. Negative 2. All right. 2x squared plus 3x minus 4. All right, I'm going to rewrite it and move my negative 4. Okay, What do I have to do next? Pull out the 2. Even though 2 doesn't go into 3, we still have to pull it out, right? Because anytime your A value is not 1, you must pull out the A value. It is not a GCF. So I get 2 times x squared plus 3/2. Good. Pulling it out is kind of like dividing it, right? So I've got to, you can think about it that way. It's 2x squared divided by 2 is x squared. 3x divided by 2 is 3/2 x. Or you can think 2 times what gives me 3. And 2 times 3/2 gives me 3. So either way you want to think about it. It's me 3/2 x and my minus 4. All right, so what's my b value? 3/2. Okay. When I want to half 3/2, normally I've been dividing it by 2, right? Yeah, but instead I could multiply by, no, not 2, multiply by 1/2. Okay? Dividing by 2 is the same as multiplying by 1/2. We know that. Okay? So instead of putting this over 2, so it's like a really complicated fraction, just multiply it by 1/2. So what do we get? All right. So that's what I boxed. I halved it, boxed it, square it. What do we get? 9/16. Write it plus 9/16. All right. In order to counteract it, we've got to figure out what we've actually done, right? Yeah. So we've really plugged in 9/16 times 2. So 9/16 times, can I put this as 2 over 1? I get 18 over 16, which reduces to 9/8. So I've really added in 9/8. So what do I need to subtract? 9/8. Well, that works because this 2 and this 16 cancel and reduce. Okay? All right, let's simplify this. I'm going to get y equals 2 times x plus 3/4. What can I forget here? Squared. Okay, and then I've got -4 minus 9/8. How could I rewrite 4? 32/8. So -32 minus 9, -41/8. So what's our vertex? Yep, -3/4, -41/8. And what's our axis of symmetry? Good. All right, to recap, here's our process. Half it, box it, square it, write it, counteract it. Okay? It'll start getting stuck in your head, and that's a good thing. Okay? Make a song. Go for it. All right? It says, when I got shown this, because I didn't learn it this way, when I got shown this, it was like, I thought one of the coolest things ever, because I think it's just such a great way to remember the whole process. Okay? All right. Everyone have it down? No. Oh, okay. We good now? Okay. Your homework is not a worksheet tonight, okay? It's going to be a couple problems from the book. It's really not that many, okay? It's like 10 problems. All right, so write this down, and then I've got it so that you can start working on it, because you still have like 15 minutes. You can probably get most of it taken care of. Did you get this down, pal? They're between